Okay, lesson 4, this is combinations. So the other half of the name of the unit here. We're going to talk about the difference between a permutation and a combination right away here. So a combination is, or combinations are, the number of ways to combine any number of distinct objects. So that's different than a permutation because we wanted to order them versus combine them. Okay, so I'm going to skip ahead a bullet. In a combination, the biggest difference is that order does not matter. Okay, so this is the biggest difference between a permutation and a combination, is that a combination, it doesn't matter what order you get the things in, it ends up as the same combination, versus a permutation, if you have a different thing first and a different thing second, that would switch. Okay, so like letters in a word is a great example of a permutation. A great example of a combination is pizza toppings, right? It doesn't really matter what order they go on as long as they all get there. It doesn't matter if the pepperoni's on top of the green pepper or vice versa. Okay, so playing cards, like a deck of a poker hand or anything like that, is also a great example of order doesn't matter. It's just a matter of what ends up in your hand. Okay, so order does not matter. The formula for this, so very similar to NPR. Now we have NCR. It's n factorial over n minus r factorial, r factorial. So this is the big difference between a permutation and a combination. And that's dividing by the fact that however many you're picking, it doesn't matter the order, right? So when we were dividing by repetitions in permutations, we're dividing by the number of things we're picking because the order doesn't matter, okay? Another way that we can write a combination, and I'm not sure why this is a thing, but if you see two brackets, kind of like a fraction without an actual fraction bar with n and r, so it might be like, I don't know, 9, 3, that would be 9, choose 3. Okay, so I don't know why that one's specifically for combinations, but if you ever see that, that's what it means. Okay, our first example is, in how many ways can 3 cards be selected from a standard deck of cards? So again, the big thing here is that order doesn't matter. So it doesn't matter if we get an ace 2 4 or a 4 2 ace, it's the same 3 cards that we're going to end up with. So if we have 52 cards in a deck, we're going to choose 3 of them. Okay, so this time I actually have my calculator. You guys, I was talking about very big numbers today in Math 30-1. So to get 52, choose 3. So on my calculator, it's old, so I have to go 52, math. We're gonna scroll over 3 times to probability, and then down or press number 3 for NCR 3. Okay, so again, on your calculator, it might be a little box, C, little box, and you enter into the little box by scrolling back. But when I hit enter, I get 22,100, so 22,100. So there are 22,100 different options for 3 cards out of a 52 card deck, okay? Because the order doesn't matter. If this was a permutation, just to compare, if we were trying to do 52 3 with NPR, we'd have a much bigger number because then the ace coming first would be a different permutation than the 2 coming first or something like that. Okay, so order doesn't matter. That's the biggest thing in a combination. It's going to be a smaller number than a permutation. How many different 3-course meals can be selected if there are 3 choices for appetizers, 4 choices for entrees, and 2 choices for desserts? Okay, there's a couple ways that we can do it. So we can kind of go back to our fundamental counting principle and we can say, okay, entree, appy, I don't know why I did it in that order, whatever, but dessert, we've got 4 choices for entrees, 3 choices for appy, 2 choices for dessert, so 24 different choices of a dinner. The other way that we can use using combinations is essentially the same thing. So if I say, okay, there's 3 choices for appetizers, I have 3 and I'm going to choose 1, times there's 4 choices for entrees and I'm going to choose 1, times, there's 2 choices for desserts, and I'm going to choose 1. If we entered any of these into our calculator, 3 choose 1 is just 3. If we think about, I have 3 options and I need to choose one of them, I have 3 different options for that choice. So 3 times 4 times 2, so same deal, we get 24. So 2 different ways to look at the same thing. If we're talking about 15 students trying out for a volleyball team, a team of 8 volleyball players, how many different teams could be selected? Okay, so again, it doesn't matter who gets selected first, it just matters whether or not you make the team. So this is going to be a combination. So we're going to have 15 students and we need to choose 8 of them. And we're using C because order doesn't matter. So again, we're going to do 15. Choose 8. So 6,435 different options. And again, like we talked about yesterday, if you just want to leave it like that, that is sufficient, but I think it's nice to get these numbers, and since I have my calculator and I can do them today, we'll do them. Okay. How many different 3 character combinations can be created using a letter for the first character, a whole number for the second character, and an even number for the third character? So for these numbers, I'm assuming we're working with digits 0 through 9. So for my first character, I have the 26 letters of the alphabet, and I'm going to choose 1. Then for the second character, I have a whole number. So I have 10 different options, and I'm going to choose 1. And then the third character, I'm looking for an even number, so that would be 0, 2, 4, 6, or 8. So I'm going to have 5, choose 1. Okay. Again, you could do the same thing from fundamental counting principle, because 26 choose 1 is just 26, 10 choose 1 is 10, and 5 choose 1 is 5. So when you multiply all that out, you get 1,300 different options. If we talk about a class with 30 students, we want to say how many ways can a committee of 3 people be selected from the class? Okay, so again, order doesn't matter. It doesn't matter who gets picked first. It just matters that you get picked if you want to be on this committee. So this is going to be 30, choose 3. And if I enter that into my calculator, I would get 4,060. Now B is a little bit different. How many ways can an executive committee consisting of 3 people, a president, a vice president, and a secretary be selected from the class? So in this case, the order does matter, because whoever gets picked first is going to be the president, whoever gets picked second is the vice president, and then the secretary. So if I get picked for the president and somebody else gets picked for secretary, that would be a different combination than if we switched roles. Okay, so in this case, there's 30 students, and now we're using a permutation to pick 3. And so let's make a little note here. Order matters here, right? So if I enter this into my calculator, I get 24,360. So there's way more options when our order matters, okay? Even though we're picking up the same number of students. If there are 10 boys and 20 girls in the class, how many ways can a committee of 3 people be selected if the committee must have 1 boy and 2 girls? So of the 10 boys, we're going to choose 1. And then of the 20 girls, we're going to choose 2. So again, we're using the C because order doesn't matter. And we're going to multiply them because if this one changes, that changes the whole combination. So then we're going to have 10 choose 1 is 10. 20 choose 2 is 190. So we have 1,900 options. Okay, so that's lower than any of the previous answers because there's, that's lower than any of the previous answers because it's more specific. So we had to pick boys and girls specifically. The next thing that we're going to look at is working with the formula. The first thing that we need to do is fix a typo. So this should be 4 factorial, not a 6 factorial. So cross that out. We're going to do 4 factorial. Ignore that. Okay, so remember that NCR is n factorial over n minus r factorial Okay, so one's a little harder to figure out than NPR was. So when I start at 10, this still tells me that my n is 10. Okay, so I can start out with 10 factorial. Okay, because if I have 10 options for the first thing, then I know that my n is 10. I have 10 things to choose from. When I end up with a 4 factorial, so normally what's happened here is if we end at a certain number, this would keep going if we like continue this. So this would be a 6 factorial. The fact that it's gone must have meant that there was a 6 factorial down here. Okay, so what this means is that we have 10 minus, we have to figure out what our r is. Okay, so if r is 6 factorial divided by 6, or sorry, this should be, if r is 6, then we have 10 minus 6 factorial with a bracket on the outside, divided by 6 factorial. Okay, so this is going to be 10 factorial over 4 factorial, 6 factorial. Because we have the 10 stopping at 7, this means that they've expanded this out. So 10 times 9 times 8 times 7 times 6 factorial over 4 factorial, 6 factorial. Those 6 factorials are canceling, okay? But this would be our final answer as far as using NCR. So N would be 10, C, and R is 6. Okay, this one, my N is 28. And then because I have a 4 times 3 times 2 times 1 on the bottom, that's a 4 factorial. Okay, so I'm stopping at 24, right? Because this would be 24 times 23 times 22, blah, 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 blah. And then that's going to cancel. So I know I have a 24 factorial on the bottom and a 4 factorial on the bottom. So the thing that I could plug in here is 28 minus 4 factorial. And then 4 factorial. So if R was 4, this thing would work. So 28 factorial over 28 factorial, 24 factorial, 4 factorial. Okay, so this is 28 choose 4. Okay, so that would be my final notation for this. Okay, if we evaluate 9 choose 4, so remember this means 9 choose 4, then according to the formula, this would be 9 factorial over n minus r, so 9 minus 4 factorial r factorial. So if we simplify that, we get 9 factorial over 5 factorial, 4 factorial. So then that's as simplified as we're going to go. We didn't need that extra equal sign. If we do 9 choose 5, we're going to get 9 factorial over 9 minus 5 factorial times 5 factorial. So this is 9 factorial over 4 factorial, 5 factorial. Notice how these guys end up being the same. We're going to do these other ones. So 8 choose 3 is going to be 8 factorial over 8 minus 3 factorial, 3 factorial. So that's 8 factorial over 5 factorial, 3 factorial. If we do 8 choose 5, that's 8 factorial over 8 minus 5 factorial, 5 factorial. So 8 factorial over 3 factorial, 5 factorial. So again, these guys are the same. Okay, so when the R values add up to the N values, then number of combinations, so the combinations will be the same. Okay, so because 5 plus 3 is 8, 8 choose 3 or 8 choose 5 is going to be the same number. You can think about it as if I have a group of 8 students and I have 3 gift cards, me selecting 3 students to get the gift cards is basically the same thing as me selecting 5 students to not get the gift cards. The combinations would all be the same. Who would get the gift cards would be the same. But if I choose to select you don't get a gift card versus you do get a gift card, I'm going to have the same number of combinations. Okay, so if I want to simplify n, choose 2. I want to put that in the formula. Whatever n is gets n factorial on the top. Then we have n minus r factorial. R is 2 times r factorial. So let's just practice plugging into the formula for that one. We're going to do a couple more examples like what we did yesterday where we have to solve for different values of n. This formula is a little bit different. So if we have n choose 2 equals 28, same deal, we're going to expand using what we know. So n factorial on the top, and then we've got n minus r factorial, so n minus 2 factorial times 2 factorial equals 28. To make this solvable, we need to get 2 factorials with the n's that we can cancel out. Whichever number is bigger, we're going to start expanding. So in this case, it's the n. So n times n minus 1 times n minus 2. I'm going to stop there because it matches the bottom. So then my n minus 2 factorials are going to cancel out. So now I have n times n minus 1 divided by 2 factorial, but I'm going to multiply both sides by that. So it's going to be 28 times 2 factorial. Okay, so then we need to factor it out. So we've got n squared minus n equals 28 times 2 factorial. That's just 2 times 1, so this is 56. Move that over, so we have it all equal to 0. Then we factor. So I need 2 numbers that multiply to 56 and add to negative 1. So we can use positive 7 and negative 8. So n is equal to negative 7 and n is equal to positive 8. Like we talked about yesterday, n being equal to positive 8 makes sense if I have 8 things to choose from. If I have negative 7 things to choose from, that just doesn't make any sense. So n equals 8 is my correct answer. For the second one, same deal, a little bit different. We're going to have n plus 2. So this whole thing is our n, this whole thing is our r. So our n plus 2 is going to go in for our n on the top factorial. Then we're going to have n plus 2 minus n factorial, this minus this factorial, times n factorial, right? This is our r value now. And that's equal to 45. So the first thing that we can do here is that we look at this one specifically, n plus 2 minus n, our n's are going to cancel. So we're going to have n plus 2 factorial divided by 2 factorial, n factorial equals 45. So now we have that same situation where we want to look at the higher one, we want to look to expand it to get it to cancel out. So we're going to have n plus 2 times n plus 1 times n factorial divided by n factorial. And again, I'm going to multiply both sides by 2 factorial to get that guy over here. So 45 times 2 factorial. My n factorials are going to cancel. I'm going to FOIL this out. So we've got n squared plus 1n plus another 2n, so plus 3n plus 2 is equal to 45 times 2 factorial is 90. If I move that 90 over, I need 2 numbers that multiply to negative 88 and add to 3. So if I use 8 and 11, if I use positive 11 and negative 8, that's going to multiply to negative 88 and add to positive 3. So that means n is equal to 8 and n is equal to negative 11. Again, negatives don't make sense here, so my answer is n equals 8. And again, you can always check this. You can actually plug in, okay, n plus 2, that would be 10. Choose 8. If you punch that into your calculator, you will indeed get 45. Okay, last few examples, we're going to look at combinations with restrictions. So just like we did yesterday, if we have a theater company and we have 13 actors, we have 8 men and 5 women, we want to know how many different ways there are to choose the company, or choose from the company, these 13, a group of 6. So there's no restrictions on male or female. So we just have 13, choose 6, right? The order doesn't matter, because if you get chosen, great. So 17, 16 is the actual numerical solution to that. Okay, so then we want to look at how many different ways are there to choose from the company a group of 6 that includes exactly 1 man. So 5 of the actors would have to be women, and then 1 could be a guy. So from the 8 guys, we're going to choose 1. And then from the 5 women, we're going to choose 5. Okay, so when I punch this into my calculator, 8 choose 1 is 8, 5 choose 5 is actually only 1. If I have to choose all 5, there's only 1 combination. I'm getting all 5. So there's only 8 ways to do that. How many different ways are there to choose from the company a group of 6 that includes at least 4 women? So we could have 4 women, 5 women, or 6 women. But because there's only 5 women in the group, we can't have 6 women. So we're going to do a case where there's 4 women and a case where there's 5 women. Add those 2 options together. Okay, so if there's 4 women, that would be from the 8 guys, you're choosing 2. And from the 5 women, you're choosing 4. So this would be, if you multiply those 2 together, you get 140. If we do 5 women, that's going to be 8 choose 1 guy, and 5 choose all 5. So this again was the 8 that we looked at before. If we add these 2 cases together, we get 148 options where there's at least 4 women. Last couple, how many different ways are there for choose? That should be 2 choose. From the company, a group of 6 women, or 6 that includes at least 1 woman. So in this case, we could do 1 woman, 2 women, 3 women, 4 women, 5 women. So that's a lot of different combinations to add together. The easier option is to do all the cases minus the case where there are no women, because now we only need to actually do 2 calculations instead of 5. So we already figured out that choosing all of the people is all of the different combinations, there's 1716, so 1,716. And then the case where there's no women is we do 8 choose 6, and then times 5 choose 0. 5 choose 0 is just 1. There's only one way to choose none of the women, right? So this is just going to be 1 times whatever this number is. That number happens to be 28. So there's only 1,688 different ways to pick at least 1 woman, right? It's just excluding that 28 different chances where there's no women. The last one that we want to look at is if there's 12 pizza toppings available for create your own pizza, how many ways can a pizza be made with no more than 3 toppings? So no more than 3 toppings means you can have 0 toppings, 1 topping, 2 toppings, 3 toppings, right? So each of those is a different situation that we're going to calculate for. Again, with pizza toppings, order doesn't matter. Okay, so if we're doing 0 toppings, if we have 12 toppings to choose from and we're choosing 0, there's only one way we can choose that. There's only one combination we can get, 0. If we have 12 toppings and we're choosing 1, there's 12 different toppings that we could get. If we have 12 toppings and we're choosing 2, there's 66 different combos. And then if there's 12 toppings and we're choosing 3, there's 220 different combos. And all of these numbers you can do on your calculator. So if we add these all together, we get 299 different ways that you can have a pizza with 3 or less toppings. Okay, so for today, your snap practice, shorter section than yesterday, same amount of questions though. So as always, if you have any questions, let me know.